Hello. In this module, we're talking about files and streams. The part one video will give an example of saving data to a file on your hard drive. And part two will show an example of opening up and looking at data from a file. And this is a really useful concept and kind of a fun chapter to talk about. So again, what we want to do in this module is write to and read from a sequential access file, meaning a file that saves things or opens things in the order that you specify. This chapter has a lot of material that is really good and really helpful, really useful stuff. Keep this chapter bookmarked for later coding that you might do after this class. We're not going to talk a lot about a lot of the advanced material in the class. So for now, if you're in my course, just focus only on those concepts that are mentioned in these slides. And for now, don't worry about the rest. So terminology, all of the data that we've stored in our application so far has been erased when we close our application. All of that data is in temporary storage, or what we call computer memory. And that's where your variables have been stored, like when you store something in an array. Those things are accessible. That data is accessible while you're running the application. But once you close the application, all of that disappears. So what we're talking about today is storing data to your computer. So when you close your application, the data is still there. So in the examples here, we'll save data to text files, maybe CSV file as well. Okay, again, more just terminology. Writing to a file means storing some data inside of a file, and then reading from is like opening it. So if you're used to the terminology of opening documents or saving documents, the terminology for a programmer is reading from a file and writing to a file. Okay, in Windows based systems, files are organized into folders or directories, and a path is the name of the disk drive in the hierarchy of directories or folders where a file resides. We talked about paths a little bit from the very first or second chapter when we were using the developer command prompt in order to compile our files. We saw how to copy and paste a file path or a folder path. So we're going to work a little bit more with paths today because we need to reference where we want to save a file to or where we want to open a file from on our computer. Okay, in order to write to or read from a file, we need to use file streams. Now, in this class, we won't get into the technicalities of exactly, the theory behind what a file stream is, but essentially a stream is an object in C# that represents data coming into an application or going out of an application to permanent storage. So in order to read from or write to a file in C#, we have to associate that file with a stream. And to do that, we create a file stream object. And if you download the slides that correspond to this video, this will be a handy slide to have as a reference point. There's several different pieces, so it's good to just have documentation that you can look up so you remember exactly the syntax for creating file streams. So basically, you first type the keyword file stream. Well, it's not a keyword, but it's the name of an object class in C#, pre-built into C#, actually from the system.io namespace. So I have this note down here at the bottom of this slide. Anytime we're using file streams, reading from or writing to files, you have to type out using system.io at the top of your code. So I type file stream, and then you give it a name. It doesn't matter what you name it. And then the equal sign, then the keyword new, and then again the word file stream. So you'll notice that this syntax is similar to when we create arrays. We use the keyword new to create a file stream object. And then inside of the parentheses, you have to include three things. Every time, you have to include three things inside the parentheses, separated by commas. The first thing that you include in the parentheses is the path, or just the file name. And I'll talk about the difference between putting a full path or just a file name in just a second. But the first of the three inputs inside the parentheses following the word file stream is the path or the file name. So if you're saving a file, this would be where you were saving that file to on your computer. If you're opening a file, this is where the computer can find that file that you want to open. And then the second and third provide different options that are available to you. And those options are detailed on the following slide. So you have to input your file mode and your file access property. So to do this, you just type literally the word file mode dot, and then you pick one of your options, and then file access dot, and pick one of your options. So here's an example. We type the word file stream, then we give it a name, totally made up, doesn't matter what you call this. Here we call it out file, equal sign, new file stream, exactly those words, and then in parentheses, first thing is the path or file name as a literal string, so it's included in quotation marks. Or you can replace this with a string variable. We'll see an example of that as I go through the example in a minute. Second element, file mode dot, and then here we've chosen create. And third element, file access, we've chosen write. So when we're writing two files in this class, we'll always file mode dot create and file access dot write. This screen shows the different options that are available for the second and third inputs within the parentheses following the new file stream keywords. In this class, we're just going to be using create for the file mode when we're writing to a file, and write for the file access. And then when we're reading from a file, we'll use the open file mode and the read file access. So for this class, we'll always use the same ones. It will always be the same syntax for those second and third elements inside the parentheses, either create, write, or open, read. But these other ones are there for your reference if you ever want to do anything different. Okay, streams flow most of the time in only one direction. So besides the file stream object, you also need to create a stream reader or stream writer object, depending on whether you're reading or writing. And whether you are reading or writing, you must create both the file stream object and the stream object. So the syntax for the stream reader or stream writer object is like this. You write the word stream writer or stream reader if you're reading, and then you pick a name, and then again, just like when we create an array, use the new keyword, and then again, stream writer, and this time in the parentheses, you just include the name of the file stream object. So in the previous example, we had named our file stream object out file. So here in this line of code, we create the stream writer object and use the file stream as our input in the parentheses. Anytime you finish writing to or reading from a file, you need to close the reader and writer and then close the file stream. So you close them in the opposite order that you created or opened them. Not closing them may lead to some problems like corrupting the file or something like that. And it's really easy to close them just at the end of the code. You just write the name of your stream writer or stream reader .close and then the name of your file stream .close with the parentheses, because close is a method. So here's another slide to have just as a reference. You open the file stream using the syntax that was taught to you, and then you open the stream writer. Then you can use this syntax, the name of the stream writer .write, and then this stream writer .write method works the same as like the write line method in our console-based applications from the beginning of the term, such that inside the parentheses you can put a string variable or a literal string or a concatenation of strings. And then when you're done, you close the stream writer and then close the file stream. So in the opposite order. Okay, so I had mentioned when you create a file stream, there are those three elements. The first one is the file path or the file name. If you don't specify a full path, the file will just save to the C# project folder, and I'll show you an example of this in a second. But if you do include a full path as a literal string, you need to either use the double backslashes instead of the single backslashes, or else use the @ character at the beginning of the file path to make C# recognize the string without trying to use the escape characters. You recall we've talked about escape characters. So for example, if you have a \n, it will think that you're talking about a new line. But here we want the backslashes to actually be backslashes. So that's why we have to double them up, or else use the @ to take the string literally how it is. Okay, I'm going to jump over. Sorry, this is my slide for the next video. I'm going to jump to Visual Studio and do the example. So here in Visual Studio, I've created a new application. I've just called it Student Scores, a Windows Forms application. And what I'm going to have this application do is save a text file that has a list of students and their scores for an assignment. So I'm going to add a button to the form, and I'm going to have the button say save, and I will call it save button. I will double click on that to create my save button click event method. Start doing some coding. Now the first thing I want to do is up here at the top in the list of namespaces, I'm going to add using system.io. That will allow me to create and use file stream and stream writer and stream reader objects. Okay, so I will just take you through kind of what the default is, particularly when you're doing assignments for this class. First thing we do is create a file stream object. So we type file stream, then we give it a name. In the slides, I called it out file. Some of the textbook slides call it FS for file stream. It really doesn't matter what you call it. Here I'll call it streamer. And then the equal sign, and then we have to use the new keyword to create a new file stream object. And the parameters are three things. First, the path or the file name. And I'll show you what happens if I just say student.txt. If I don't put the full file path, I'll show you where this ends up saving the file. Second thing is the mode. So we have file mode dot create, and third is file access dot write. So again, anytime you're writing to a file, you're always going to use file mode dot create, comma file access dot write. Those exact words. The only thing you're going to change is where you want the file to be saved to and what the name of that file should be. And then don't forget the semicolon at the end. Then we want to create a stream writer object. And again, it doesn't matter what you call this. Just call it SW. And then create a new stream writer. So we're both declaring and creating the object. And this only takes one parameter inside the parentheses, which is the name of the file stream. Then we can write stuff to the file. And then at the end, we want to always remember to close our stream writers and file streams. So we have first, we close our stream writer using the close method. And then we close our file stream also using the close method. Okay. Now, to actually indicate what data you want to go in that file, you use the write method. You use the name of your stream writer dot write, and then in the inside the parentheses, you indicate the string that you want to be written to the file. So it could be a literal string, like if this is the name of student scores, I could say John had a score of 99%. And the new line, Jane had a score of 98%. Now, if I run this isn't a very interactive program. It's not going to, I didn't put any text boxes or anything yet. I'm just going to have it create a file that just has this literal text that I put in the code. But of course, you could replace that literal string with, like the text of a text box that's the input from a user you could save to a file or something like that. So here's my form. All I do is click on the Save button. And what that does is wherever I've saved my code to on my computer, so in this example, I've saved my code to a folder called Code on the Desktop. If I open that project folder and then go into the subfolder, and then the bin subfolder and the debug subfolder, what you'll see here is, first of all, when you click Start Without Debugging and it compiles and runs your application, this is where it actually stores your executable file. So this has been doing this for every single GUI application that we've created. Every time you've created one, it creates a .exe file in that bin debug subfolder. But what we've also done here is it has created this file called student.txt, and it's just put it in that folder. And let me make sure you can see it. Okay, I open up the file, and here it's written my text. Now I made a mistake because I tried to put a new line in there, but actually that write method puts everything all on one line. It ignores your my new line space character, it just ignored. So if I wanted these to actually be two different lines inside this text file, then what I would need to do is put another write statement. And that would put them on separate lines in that text file. Now, if I want that file to be saved somewhere other than that default folder, so let's say I want it stored specifically at C:\users Jordan desktop code. Okay, I can specify a specific path. But here, you'll recall that if you have a backslash, it looks for an escape character. So it tries to do like a \u. If I had a \n, it would try and put it on a new line. This doesn't really make sense to C#. So if you want it to recognize these backslashes as actual backslashes, you either need to double them up, or what you can do is at the beginning of your literal string, if you type the @ symbol, what that does is the @ symbol, anytime you have it right before a literal string, is it ignores or it treats the backslashes just as a backslash text. It doesn't allow any of the escape characters like a new line character. What becomes even more useful is instead of hard coding a specific path here, is if we allow the user to specify where they want to save the file. So we could do, for example, add a text box. And I'll just add a label as well. To indicate that that text box is for a file path. I will call that text box the path text box. So then here we could let the user decide, well, this is the directory where I want to save this file. So back in our code, we could save the path input by the user as a string. So we can declare a string variable called path, and that will be whatever the user inputs into the path text box. And then here, when we're creating our file stream, instead of inputting a literal string, hard coding exactly a specific place on the computer, we can just replace that with that string variable path. So now the file should save to whatever path the user input. If I run this, then now I can type in, oh, I want this to be saved in this location and have it be called students.txt. Then I'll click the Save button. And then if I navigate over to my code folder, there's the file that we created. And it's still putting those on the same line. Why is it doing that? Oh, I know why. I made a mistake. Okay, so back in our code, this is just like what we learned at the beginning, the write line and read line methods. You can actually use write line. If you just do write, then it will keep everything on the same line. But if you do write line, then these will go on separate lines in your text file. So now if I were to run that and click the Save button, then it would save that student.txt file in my code folder. And when I open it up, it will look like this. Now, another thing that you can do, I'll show you a little trick, is another control that we haven't talked about before. It's not even in the list of common controls, but if you go to all Windows Forms, there's a control called the Save File Dialog. And if you drag that onto your form, you won't see it visibly on the form, but it's created a control that it's called Save File Dialog 1. You can rename that control if you want, just like any other control. It has properties. I'm just going to leave it as Save File Dialog 1. Then what you can do is back in your code, what the Save File Dialog does is it brings up like a pop-up window where the user can click to save the file. I mean, if you're used to saving file, like when you save a file in Microsoft Word, you don't manually type in the file path. You choose it from a visual application. So the way that we can do that is in our code, instead of having that path come from the text box, we can instead have it come from that Save File Dialog box. And how you do that is you type the name of the control and then dot file name. Oh, and actually I forgot one step. You actually have to open the dialog box. And the way you do that is by typing the name of your save file dialog dot not open, show dialog. Okay, so what this line of code does is it opens up a dialog box where the user can select a file path and file name. And then once the user selects one, it will be saved as a string variable called path. And then that path will be used in our file stream. So let me just show you how that will work. So here I don't even have to, I probably should delete this text box because we're not using it anymore. If we just click the Save button, then it opens up. Whoops, you can't see that. Let me go back and share that screen. Okay, so now, sorry, we don't have to type anything here, and I could probably just delete those because we're not going to actually use this anymore. Because now when we click Save, what happens is it pops up this dialog box, and we can go and we can choose where we want it to save, and we can save it as students.txt. And then if we navigate over to that folder, we should see our file and open it up and see that it saved what we had asked the code to write to the file. Okay, one more thing in the code. Okay, so let's say instead of just, well, let's say that we have an array. We often use arrays with writing files. So let's say that we have an array of student names. And just for the sake of an example, I'll just have 3. And I will input them manually. John, Jane, Bill. And let's say we have a parallel array of student scores. Those will be, let's say, doubles. 98, 78, 83. Whoops. That should be double, not string. Yeah, I'm creating an array of doubles. Sorry, I was just mindlessly copying the code above. Yeah, this is an array of doubles. It's a parallel array to this array of strings. So saying element 0, John got 98, element 1, Jane got 78, element 2, Bill got 83. Okay. Now, if we have an array of information, then here, instead of just typing in a literal string for a write line, we're going to do one line for each element of the parallel arrays. And so again, like we almost always do when we have arrays, we're going to use a loop with them. So we're going to, for each element in the array, we're going to add it to our file. So for int I equals 0, I is less than student names dot length I plus plus. So meaning for every element in the student names array, we're going to write, well, put on a separate line that element of the array. And then what I'm going to do is I'm going to add a comma, and then I'm going to add their score. So that element of the student scores array. So what this will do when the for loop runs is it will start at 0 and it will write student name element 0, which in this case is John, and then a comma, and then student score element 0, which is 98. Then in the next iteration of the loop, I is equal to 1. So on the next line, it will write student name subscript 1, which is Jane, followed by a comma, and followed by student score subscript 1, which is 78, Jane's score, and so on. Now the reason I added a comma here is because I'm going to create a different type of file. I'm going to actually save this as a CSV, which is a comma separated values file, instead of a text file. So if I run this, oh, actually, first what I also want to do is just delete these so I don't get confused. So again, this is just a very simple application. All we're doing is saving a file, but you could add this, together with other functionality on a screen, have the user input some stuff, and then save it to the file, which is what you'll do on the homework. But this example only demonstrates the part where you save it to the file. And I've just hard-coded in that data in those parallel arrays. Now, if I run this, and you might not see this, but all I'm doing is clicking on that save button. Well, but I'll show you because I want you to see. Okay, it pops open the dialog box, and I want to save it in this code folder, but I'm actually going to save it as student scores.csv. So comma separated values file is a file that you can open in Excel, and every element separated by a comma is represented by a different column in Excel. So if I save that file and then jump over to my folder, it has saved that comma separated value file, and I can open that in Excel, and it's put the names in one column and the scores in a separate column because these were separated by a comma.